Hi, this is Kevin Trainer. Welcome to my lecture on Chapter 11. Welcome to my lecture on Chapter 11 of Interaction Design, 4th edition. And Chapter 11 is entitled Design, Prototyping, and Construction. So now we're getting a little more practical. So what's this chapter about? Well, we're going to talk about prototyping. Pretty extensively. Conceptual design and concrete design, in particular, how they relate to prototyping, using the scenarios, and again, how that relates to prototyping, generating prototypes and construction. Okay. Probably not every construction-related issue, but some interesting ones having to do with well, the builder maker movement and how that might relate to interaction design, and in particular to prototyping, although the chapter doesn't draw all those pictures for you. Certainly the lecture will. Right. So what is a prototype? Well, let's just take a segue and let's go look at the definition of prototype in the OED, the Oxford English Dictionary, and see what the various definitions are. So the first one is the first or primary type of a person or thing, an original on which something is modeled or from which it is derived, an exemplar, an archetype. So prototype in this sense, I think, is pretty close to what we're talking about in prototyping for interaction design. It's a first version. It's something that we can refer back to. Our sense of it is maybe a little bit more specialized because this definition of prototype doesn't really take into account that some prototypes can be highly detailed and some can have minimal detail, which we're going to call high fidelity and low fidelity. So in that kind of a design sense, that's not really captured here. Okay? The second definition, I think, is often surprising to people. In model making, a full-size original of which a model is a representation on a reduced scale. So this always surprised me a lot as a model railroad enthusiast. I was always surprised that when model railroading people would talk about the real trains, talk about the locomotive itself, they would call it the prototype, okay? Because it is the thing after which we are modeling. And to a certain extent, that meaning really starts to capture what we're doing with a prototype. We're trying to have it be a reference, okay? It's something we can refer to, okay? Now, in this sense B, definition B, in model making, at least in this kind of modeling, there is typically a prototype, a full-size original that we're trying to create a scaled likeness of, okay? So we have something to refer back to, okay? We're, in the work that we're doing, we're in a different part of the creational process because we're trying to create something that perhaps hasn't got all the oomph of the full-scale real version, right? But we do have the sense that we do want it to be the thing to refer back to. right? Well, what did the prototype do? Well, what did we learn from the prototype? So in that sense, we're using the word the same way. Then we have 3, a full-size working version of a new vehicle, machine, etc., of which further improvements may be made. A preliminary version made in small numbers for evaluation, or from which improved or modified versions may be developed. That's pretty close to the way we're using it, especially when you talk about low fidelity prototypes and high fidelity prototypes. So when we're talking about physical devices, something as big as an automobile, one of the difficult things to do is just to build something to that scale, right? And when a lot of what we're trying to figure out is the styling, it may not be really required to build everything to that complete full-size working scale. So this, I think, gets to some of the issues that we have of why we might do a low fidelity prototype or a high fidelity prototype. And the kind of work that we're doing for information systems or for interactive devices, the size probably isn't that daunting, okay? But the detail is, right? So we might start out with a low detail prototype and then move up to a high fidelity, high detail prototype. And then, so that's it. So what's kind of interesting is that the word has a couple of uses. They all relate to this kind of prototypes being something to refer to, okay? And if we're creating the prototype before the full-scale thing, then maybe it's not full-scale. But when we come around full circle and we're trying to create models of things that are already created for, well, typically for our pleasure, as in with a model train, well then the prototype is the full-scale thing because it is the thing to be referred to, right? It is the authoritative example. Interesting, huh? All right, that's enough time on that. So we have all kinds of questions we're going to go through with relation to prototype. What's a prototype? Why do we do it? Different kinds of prototyping for us, low fidelity, high fidelity, compromises in prototyping, and I think there's a really good discussion of that within the chapter, and then a discussion of why we need to differentiate between our prototype and the final product. Okay, in this case, we'd say because the final product needs to be engineered, and we'll explore that in a bit. Okay. What's a prototype? Well, in physical design fields, prototypes are often small-scale models. Okay, but they could be a full-scale model, as we saw. So. So we might be talking about a miniature car, a miniature building or town. The examples that we see here on the slide and in the chapter of the book are, we've got, I think, 3 different things that were printed with 3D printers. And certainly there's a lot of prototypes that are either full-scale versions or small-scale versions of whatever is being designed that are currently being 3D printed. And here, yeah, in fact, there's even a video that you can go see from the Disney folks, as I recall. Yeah, Disney research, where we can say, we are 3D printing like a plush toy bear. Kind of interesting. Okay. In interaction design, a prototype can be, among other things, a series of screen sketches. It could be a storyboard. It could be a PowerPoint slideshow. It could be a video simulating the use of a system. It could be a lump of wood, like the inventor of the Palm Pilot did when he just wanted to check out the form factor. He machined a block of wood to the approximate size of the device, and then he just kind of lived with it. He said, how do I like this form factor? It could be a cardboard mock-up. It could be a piece of software with limited functionality written in the target language or in another language. So in the system development biz for computer-based information systems, a lot of times we're talking about a prototype. We mean it's a software-based prototype. It might be built out of the parts that we're going to build the end product out of, or it might be built out of some kind of a prototyping language or prototyping kit that hasn't got, say, the performance characteristics or the robustness of the eventual, say, software technology that we're going to build the product out of, but it's easy to prototype with. Okay. Why are we going to prototype? Well, our point of view as user-centered interaction designers is we need to be able to evaluate alternative designs, and to do that we need feedback from users or people who come to represent the user point of view. And to do that, we need something to get feedback on, okay? And something probably short of the full-blown product because, for instance, we probably can't afford to manufacture 2 alternative products and then see what people prefer. We would like to do that more experimentally up front. We want a chance for stakeholders to see, to hold, to interact with some kind of prototype that's going to be more engaging than a document or a drawing. Okay, so again, sometimes a document or a drawing is a low fidelity prototype. Okay, so something that they could see and hold and interact with would be a more high fidelity prototype. The more that people can have a real experience, the more they can communicate with each other effectively about their likes and their dislikes. You can test out ideas for yourself. It encourages reflection. Okay, again, what we're trying to avoid is just a one-cycle design. We like this idea that it's going to be iterative. We're going to design, evaluate, design, evaluate, design, evaluate, we're done. Go produce. Prototypes answer questions and support designers in choosing between alternatives. Kind of like that cycle I just described. There's a discussion in the book that if you don't catch the transition, can maybe be a little bit misleading. But here's what we're trying to say. There is, in creating a prototype, something short of the final product that we can use for evaluation. There's always a filtering, which is to say, we're not going to reproduce all the characteristics of the end product, okay? So that means that we have to choose which characteristics we want to emphasize and which we don't want to emphasize, either because we're trying to evaluate things separately or just the sheer cost of things. I mean, if we're going to reproduce all the characteristics faithfully in full scale, well, then we don't have a prototype anymore. We have a working model, right? We have the real product. Okay, the only difference perhaps could be that maybe it's not manufacturable yet, okay? But typically prototypes are somewhat short of that, and they focus on some dimensions of the user experience and not on others, and that is filtering, right? The things that you see are the things that we're trying to emphasize. The things that you don't see are the things that we're not. So we have a couple of tables here, and they go through what kind of things that we could be filtering for. Well, appearance, data, functionality, interactivity, spatial structure, by which we mean physical form factor, right? Material, okay. Are we going to have a wood one? Are we going to have a stainless steel one? Are we going to have a glass one? Resolution, the level of detail in all kinds of things, including the screen on the device. The scope, the range of what's going to be covered. Okay, so by its very nature, if we're creating something short of the real deal, we're going to emphasize certain characteristics, we're going to de-emphasize others, and thinking that this is intentional is, I think, an important thing to do. You've only got a certain amount of time and money and attention to do a prototype, so you definitely want to filter for the things that you want to know the most about, the things that are perhaps the riskiest. What to prototype? Okay, well, I guess that in a certain sense gets down to what are we filtering for? Okay, well, again, where's the riskiness in this enterprise? Technical issues, okay? Workflow, task design, screen layouts and information it displays. Difficult, controversy, or critical areas usually having to do with the job itself, I think, is what we're talking about there. So that would get us back to things like workflow, task design, although it could be the other things. Okay, so again, what do we want feedback about? Well, we want feedback on the issues that we're the most uncertain about. Okay? What we're trying to do is squeeze risk out of the project as early as we can. That's my project manager's point of view coming to the forefront. Okay, so we can create a range of prototypes, all right? And some could be considered low fidelity prototypes, and some could be considered high fidelity prototypes, but they're all kind of relative to each other, right? So for instance, I think you could easily say that one particular kind of prototype was lower fidelity than another kind of prototype. But you're just going to pick a kind and you're going to do it on the basis of it being sort of economical to do, and you think it's going to give you useful answers. So what might a low fidelity prototype be? Well, it's going to use a medium which is unlike the final medium. Okay, it might be paper or cardboard. It's quick, it's cheap, it's easily changed. Okay. Examples: sketches of screens, task sequences, post-it notes, storyboards. Wizard of Oz is kind of interesting because, as I understand the Wizard of Oz, as they explain it in the textbook, it's a lot like an approach that as some people call Mechanical Turk, which is perhaps in a multicultural world a bad choice of words, but it comes from the idea that there were at one time carnival people would have these machines which would give answers to things, and they would appear to be machines, but there would actually be a person kind of hiding inside. Okay, and so the Wizard of Oz approach is kind of the same thing, where, like in the Wizard of Oz, we have all these manifestations that we think are sort of the manifestations of a great and powerful wizard, but they're actually the manifestations of a fairly common elderly tinker who is kind of fooling us. Okay, and so we could do something like that. There's a good description in the chapter of one of the case studies that's available through the website of how I was going to say cell phone makers, but I would say now smartphone makers, how they do low fidelity prototyping. And you can see from the description that a lot of them do it on paper, right? So they do a lot of their prototyping as to what the behavior is going to be just on paper, right? And so that would be low fidelity prototyping. So that's worth some exploration if you want to see more concretely how they do that. Storyboards are very popular, and there's, I think, a good discussion of storyboards in the chapters. So people often use storyboards with scenarios like we talked about in the last of the chapter, bringing out more detail and maybe a chance to role play. It's a series of sketches showing how a user might progress through a task using the device. And this is the kind of thing you might use early in design. And it's really like a comic strip. Okay, let's see if we can find a storyboard. Here's a storyboard on slide number 14. A storyboard depicting how to fill a car with gas. And it's like a cartoon. We've got these panels, and you look at each one, and they tell a part of the story. And it's okay to, to label them so you can see what part of the story is going on. And one of the things that I think they do a pretty good job of in the chapter is to say, you don't need to be a graphic artist to do this. With a little work, most of us could create the art that we see in on this slide 14. And we would have some idea about how we saw this interaction happen, right? What's kind of interesting for me here, though, when I look at this storyboard, is I'm not sure what interaction we're trying to depict, right? Because we drive to the gas pump, we take the nozzle from the pump, we put it into the car, we squeeze the trigger, replace the nozzle, we pay the cashier. I think it would be more interesting to see a sketch of a transaction where we pay at the pump Okay, so we have to interact with the pump as an information system at the same time as we need to fuel our car, and we need to arrange to pay and get a receipt and all that kind of stuff. That would be a lot more interesting to me than the story that we see here. But perhaps we'd take a little more drawing ability and a little more design work, right? But the idea here that you don't have to be a super artist to do this is, I think, it's an important point. So let's look. I want to mention here, I went back to slide 13. I just want to point out that this is not an example storyboard. Sometimes when they create these slide decks for us, they make a mistake. And this is a table from the book, the advantages and disadvantages of low and high fidelity prototypes. Probably should have been an example storyboard. And so we kind of get the idea here about why we might want to do a low fidelity prototype and why we might want to do a high fidelity prototype. Okay. A really nice low fidelity prototype that we can do of conventional information systems is the card-based prototype. And we talk about card-based, these are kind of on big index cards, right? And as you can see, and they're saying 3x5. I might even use the bigger ones. The 4x6 ones would be a little more appealing to me than 3x5 ones. Each card represents one screen or part of a screen. People often use this in website development. So what we're seeing is we're seeing the parts of some kind of a scenario or use case going on, and we're seeing what it looks like in the user interface. Okay. So that's a really promising idea that I like a lot because it's easy to do. Now, I think that the card-based idea is interesting because it's so, you don't even need a computer to do it, right? You can just kind of sketch it, okay? Although there are many low fidelity prototyping tools, there are very many prototyping tools that we could use to do the same thing on maybe bigger sheets of paper, even faster, if we were better at using the automated tool than we were at drawing things by hand. So whether it's actually card-based or whether it's low fidelity screenshot based, I kind of see them as being the same thing, right? All right. Wizard of Oz prototyping I already talked about. This is the idea that you're going to appear to have an intelligence in the system that's not there. Okay, so you're going to have the user and they're going to say, well, I do this, and you on the other side are going to say, oh, system does that. And they're going to say, now I do this, and you could say, system does that. Okay, what's wrong with this approach? Its reproducibility is questionable. All right, it's good for exploring ideas, but of course it's going to depend upon not only the user but also the wizard who's going to pretend to be the system. High fidelity prototyping. So high fidelity prototyping uses materials that you would expect to be in a final product. The prototype looks more like the final system than a low fidelity version. High fidelity prototypes can be developed by integrating existing hardware and software components. There are times when you can just take, say, kits or existing pieces and combine them together and get a high fidelity prototype. The danger in a high fidelity prototype, and this has always been a prototyping problem, is that the users come to believe it's like, oh, this is great. So when can we start to use it? And it's like, oh, sorry, this was a prototype. This is this doesn't actually work. It just appears to work. So you could get the feel of it. We have to go do the rest of the technical design and we have to build it. Well, if you don't really address that issue up front, you can have some really disappointed people after their interaction with the prototype, where things, if it's a real high fidelity prototype, well, things seem to be working, right? But more typically, right, the shortcomings of a prototype are more obvious to the user, okay? And this has to do with the fact that we're not building the product itself, so we're building approximations of it. Remember the filtering ideas. Okay, we're trying to concentrate on certain things, which means that certain other things are not being concentrated on. So when we do that, we're compromising. Okay, so all prototypes that are short of the real product are a compromise, right? So how are they compromises? Well, a lot of different ways they could be compromises. So if we're doing software-based prototyping, perhaps it has a slower response. Perhaps the icons are sketchier. Perhaps it doesn't have all the functionality. Perhaps it has the response and good icons and functionality, but it doesn't have the ability to scale up to the number of users that we're talking about. For instance, we could very easily create an experience for a single user, or even 2 or 3, that whatever software and platform we used could not scale up to 10,000 users, 100,000 users. I mean, we have some applications that we interact with every day now, things like Facebook and Twitter and those kinds of things that have millions of users, probably at least hundreds of thousands of simultaneous users. So it would be really easy to come up with a prototype that was highly functional, but wouldn't scale up, okay? 2 common types of compromise: horizontal and vertical. Okay, so what if we can't provide a prototype that shows every little bit of the system? Well, then how could you decide which parts to include? Well, if you took a horizontal approach, you would cover a wide range of functions with little detail. In a typical system, maybe this would allow you to navigate across the main navigation bar to all the parts of the system, but you wouldn't be able to drill down very far before you got the things that didn't actually work. You'd click on something and it wouldn't be a real link, or it wouldn't be a real button, okay? Because but you would get a really good idea about the breadth of the application. With a vertical approach, we do the other thing. Perhaps when you're in the top of the application, you can see all the places you can go on the navigation bar, but perhaps only one of the links is actually live. Okay, all the other ones are dummies. They don't go anywhere. Okay, but perhaps for one of the functional areas, you can drill down pretty far. That would be a more vertical approach. Um, so compromises in prototypes are nothing that we should ignore, which is to say, it's the compromises that make them affordable. All right. Okay. It's because we're using prototypes that are of their nature a compromise that they're affordable to use. The thing that we have to make sure is that we don't confuse the user to come to believe that the prototype is just is the product itself. And this is always a problem as you get to higher and higher fidelity prototypes. Okay, so in using this prototyping approach, we want to be able to capture both is sort of all the parts of the design process. We're going to go back and mention the parts of the design process here and remind you that we could do this via prototyping. Okay, so at the end of the last chapter, we had requirements. And we had expressed the requirements either as a scenario or as a use case or as a specialized kind of use case, or as I mentioned, a user story. Okay, so we have all of those things. All right, so now we need to transform these requirements into a conceptual model. A conceptual model will remind you is an outline of what people can do with the product and what concepts are needed to understand and interact with it. Okay, they show us a mood board in the chapter. The mood board that they show us is this kind of all materials, right? So you get an idea about the fit and finish from that. But you could create a mood board that would have more dynamism in it. Okay, you could see somebody using a product like this, and you could see the situations that they were using it. So it's certainly possible to create a mood board that I think is more in keeping with an interactive product than the one we saw in the text. And then when we're trying to come up with the conceptual design, we could use prototyping to help. So what we would do is we try to, let's say we had two alternative conceptual designs. What if we did a storyboard for each one? See what they would look like, get some feedback on them. The next thing we want to think about is there a suitable metaphor for the interface? So interface metaphors combine familiar knowledge with new knowledge in a way that will help the user understand the product. So there are 3 steps in this. You have to understand the functionality, you have to understand potential problem areas, and you have to generate the metaphors. Now, they give, I think, good advice in the book is, of course, anytime using some kind of a metaphor, by its very nature, it's a comparison between the real activity and some metaphorical activity. And when we're talking about these potential problem areas, it's important to pick a metaphor that's good with the problem areas. Okay, we don't want to pick a metaphor that's great at helping the user through the stuff that's easy to do, but the metaphor kind of breaks down when we get to the hard stuff. No, probably not. So how do we evaluate a potential metaphor? Well, how much structure does it provide for the task at hand? How much of it is it relevant to the problem? You know, how well matched are they? Are these two things that are really well matched up to each other, or just a tiny bit? Is it easy to represent the metaphor? Will the audience understand it? How extensible is it? Which is to say, as you keep going on to further parts of the real activity, is there yet another part of the metaphor that applies? And as a teacher, I try to use metaphor all the time. And it's kind of interesting because I try out some that are appealing to me, and I find out that they're not appealing to students. And then sometimes I'll see a metaphor that's used in a text, and I think, well, why don't I try that, even though it's not something that I would have thought of? And it turns out I get a really good response from the students. So obviously, it's not, the best ideas are not only my original ideas. Okay, another thing we have to consider is what kind of interaction is this, and what type of interface are we going to use? And again, we're just going to go back to the earlier chapters from the textbook and remind you, what kind of interactions are there? Well, there's instructing, there's conversing, there's manipulating, and there's exploring, okay? So which of those match up to which parts of your activity, okay? And it might not be just one. There's a good discussion in the chapter of how one particular problem is a combination of, I think, instructing and conversing. And either we're going to be using some conventional kind of interface, like a web application or a smartphone app, or perhaps we're using one of the fancier kinds of interfaces that we talked about back earlier in the book. Is it a shareable interface? Is it a tangible interface? Is it augmented reality? Okay. You probably just want to kind of think through these things and see if there are any opportunities there. We need to expand the initial conceptual model. So what functions will the product perform? Okay. What will the product do, and what will the human do? Task allocation. Now, for me, I think I mentioned when we were working on the last of the chapters, I'm very much on use cases. And to the extent that I teach agile approaches, then I'm into user stories. And these are both tell what's going to happen between the system and the human to get the job done in a story kind of a way. So if in fact we already have a use case, or if we already have a user story, well, we have a start. Okay, that's where we should be starting. How are the functions related to each other? Are they sequential? Are they in parallel? How might we categorize the actions? Okay. What information is going to be needed? What data is required to perform the task? How's the data to be transformed by the system? For me, having already created a use case by the time I get here, I have a very loose idea about how the interaction is going to work. I've tried to be pretty general in my use case. You know, the actor does this, the system does that. I don't say exactly how they do it. I don't say what exactly they do in the user interface, at least when I'm doing a good job of it, I don't. But I've got the basic story down, okay? And now we've got concrete design, okay? So how is concrete design different from conceptual design? Well, I think it's really important to take a pause here and say that for a long time, we've been trying to get designers to not get too specific too quickly. Okay? I mean, this I can go back 35 years to structured analysis and design, which was a systems analysis and design approach. And we talked about logical design and physical design. And in logical design, we were talking about how the information flowed and all that kind of stuff. In physical design, we were talking about devices and screens and more physical detail. Okay, and the idea is if you get too specific too quickly for exactly how the product's going to work, a lot of times you leave opportunity on the table. Well, that's just the kind of thinking that we're doing here. Okay, now between conceptual design and concrete design, do we really think that your mind is going to have a toggle switch? Conceptual, no, over to concrete, back to conceptual, over to concrete. Well, we might do that switching back and forth, but I think realistically, we think that you're going to have a holistic approach to this. Okay, but we want you to have a good idea about how things are happening conceptually before you bother yourself with the concrete details. Because we don't want you to get so invested in a particular conceptual approach because you've created so many of the details of that design that you can't walk away from it. Okay, and that I think is as much the justification of looking at this as a two-part activity as any that I've heard. So, what are the aspects of concrete design? Well, color choices, icon design, button design, specialized interaction devices, those kinds of things. We have to consider both the user characteristics and the context that they're going to be using the system in. So in terms of their own characteristics, what are their unique abilities? How does that have to do with, say, accessibility in the system? In terms of the context, are there cultural things? Are there industry industry culture things? Are there more overall kind of national culture things? There's a good discussion in the chapter of how one size doesn't really fit all, okay, and how certain bundles of social solutions are going to appeal to one group of people, and maybe another bundle is going to appeal to another group, and that might have to do with their cultural differences. So to drive this, we're going to need to either have scenarios, use cases, or user stories, right? So hopefully by the time you've gotten to this part, you have those, all right? And what you're trying to do is you're trying to flesh them out in terms of, okay, what's the interface? How's the user interface actually going to work? So these scenarios can be used throughout the design to do a number of things. You can use them as a basis for the overall design. You can use them as the scripts that people can use as they go evaluate your prototypes. You can use them as concrete examples of tasks. You can use them as a means of cooperation across professional boundaries. Okay, so if we have different professionals who are participating, perhaps we have a systems analyst and an interaction designer and a programmer, okay? Well, perhaps the scenarios, or in my cases, use cases, are what we can use as a way to keep us all on the same path. There's a pretty good description of plus and minus scenarios in the chapters, which is you can use a scenario. You can create like a happy day scenario, as we say in use cases, where we describe everything going well with the product, and that's what we call a plus scenario. And then you could create a scenario where the user has a bad experience, and that's a minus scenario. And the idea is that we could have the team be aiming for the plus experience and certainly not for the minus experience. You can generate a storyboard from a scenario. You can generate a storyboard from a use case. You, I think, could generate a storyboard from a user story if you were using the Agile approach, but user stories are pretty lightweight, so you might have to invent some of the detail. And here are some of the sketches that you could use. Here are some of the things that, here are some artistic suggestions, okay? Here is the graphic from the book, the photo that showed a bunch of low fidelity prototypes created for smartphone user interfaces. And as you can see, they're all on paper. Explore the user's experience. So you can use personas, card-based prototypes, or sticky notes to model the user experience. One of the things that we can do, remember the fact that we said that we're probably not going to be able to create a prototype that captures the entire experience. That we're going to have to, that when we make the prototype, it's a filter of a certain kind. We're only going to concentrate on some things. And then we also said, well, when you think of the application that we're building, we might try a horizontal kind of approach where you could see the full breadth of it, but not the full depth of any one part. Or you could think of a vertical approach where you could see the depth of one part, but not the depth of the others. Okay. We have here these design maps, experience maps, customer user journey maps, which are ways to express how the experience would go for a particular user. Okay? So for instance, you might take a particular persona, and you might show how that persona might use the system kind of all the way through. Okay? And there are several versions of this, and there are two concrete examples that we give within the chapter. One that's a wheel for things that are a little more cyclical, and one that's a timeline for things that are a little bit less so. And I think we have them here. So here's the wheel one. Um, this is an experience map drawn as a wheel. Okay, so we're taking a particular persona. In this case, this is our probably our business traveler, I think. And what we're trying to do is we're trying to understand. Okay, if you're looking in the center, we have the name of the experience, flight to New York City. Who? Okay, so the description, Richard. This is for the persona Richard. So we have the experience before the flight, during the flight, and after the flight. And so we go around and we look at all the different parts of the experience. And then on top of that, we even have these icons that we can use to these experience icons. We have a face. How can this be a positive experience? A make or break moment. And then we have these information icons. What kind of information do we need to make this a good experience? So here is, in a way, this is a bit of a prototype. I mean, you can look at this and you can kind of see the experience flow, right, for Richard. And you can kind of feel your way through it. You can kind of say, oh, well, yeah, I hadn't thought of that issue. Yeah, okay, I think we've covered that issue. You can go through that in a pretty useful way. The next one is more of the timeline kind of approach. And this is called a design map, okay? And so we have Megan delivers a presentation, and so the persona is Megan. In this case, the use case or the user story, it delivers a presentation, okay? And we have the steps in light blue. We have questions in yellow. We have ideas in pink. And we have comments in green. So pretty neat. Again, this gives us the opportunity to walk our way through this without having built it yet. Okay, so it is a prototyping approach. Okay, in this case, it's a paper-based prototyping approach. Okay, so sorry about that. That's what I'm going to do. I'm going to get that up here. There's a nice discussion in the end of the chapter about a particular kind of construction. And in this case, construction as it would relate to prototyping. Okay? Now, there are a number of software packages, which we've not discussed yet, that will allow you to create either low fidelity or high fidelity prototypes. Okay? And these are probably the best at creating prototypes of typical user interfaces. User interfaces that are embodied in classic web applications. User interfaces that are embodied in classic smartphone apps. Okay? User interfaces that are embodied in PC applications that run on the desktop in a dedicated window that is not a browser. Something like Photoshop or Excel or Microsoft Word or some kind of integrated development environment for a programmer like Eclipse, right? So if in fact we want to prototype those kinds of things, well, then there are tools that are going to allow us to do certainly create a paper version of what that interface is going to look like, and then there are ones that will allow us to simulate that experience without having to create the product itself. What if what you're trying to create is not so mundane? Okay? What if you're trying to create a new physical interactive device? What if you're trying to create a microwave? What are you trying to create? I don't know. What if you're trying to create some kind of game? What if you're trying to create some kind of thing that you interact with it and it creates behavior? How would you do that? Well, it turns out that there are some cool tools that are fun to learn about and fun to talk about. And this whole area is kind of generally called physical computing. And it's called physical computing because we can create software or configure software that will run on a very simple computer and will interact with devices in its environment. So we can say touch a switch and it can light a light, okay? Or we could open a door and it could sound an alarm. Or we could press on one side of a dimmer switch and it could lower a light. Or perhaps it could lower the volume of sound. Okay, so we could, the idea is have the computing system create, one, to sense things in the environment that are not your classic type something into a box and click the enter key, all right, push a switch, trip a sensor, that kind of stuff. And the other way is have it create behavior in the environment that's just not your classic displaying things on a screen. So things like ring a bell, open a shade, start a coffee maker, cycle the filter on your swimming pool, all those kinds of things. Well, there's a whole bunch of people doing this stuff. And one set of tools is talked about in the textbook. It's based upon a kit called Arduino, which is a very simple computer processor. And what you do is you build and you code prototypes using electronics. And so you're really building something here. You're creating a unique physical product. So the toolkits that they talk about Arduino, which is a simple processor and a very popular one. It has competitors, one of which I'll show you in a couple of minutes. There's the LilyPad toolkit that allows you to do electronic things with fabrics, which seems kind of pretty interesting. There's a sense board that allows you to sense input. There's this Makey kit they talk about. And these are designed for use by a wide range of people, and they not just computer nerds. Okay, so of course I'm teaching this course in an iSchool, so some of the people in the course are in getting a library degree, for instance. And for instance, libraries have maker spaces, right? And these are the kinds of tools that people have in maker spaces. There's a good discussion in the chapter about some work that was done in having people from their 60s into their 80s use these kinds of tools to design and to make things. And they found it very enjoyable, and they were good at it. So these things can be used by children, these things can be used by older adults, and of course, they can be used by people in the middle. This is an Arduino board. Okay, so it's pretty physical looking stuff. It's kind of raw computer stuff. They're very affordable. Okay. This is the Makey toolkit. So you can see that we have ways to complete circuits with the alligator clips and that kind of stuff. We have physical computing kits. So here's a group of retired folks playing with the Makey toolkit. Pretty interesting stuff. So I just want to point out that these aren't the only brands. So I happen to be a fan of a small computer that's been around. It's just had its first birthday, and I've taken you to its homepage. It's called Raspberry Pi, Pi as in the number pi. And it's an educational platform. And let's see if we can find a picture of a Raspberry Pi. I don't know how we got there. I hit something that I didn't intend to hit. But education resources. So let's go to that. Let's see if we can find a Raspberry Pi here. Used to be able to find these things pretty easily. Forums, community. So there's a lot of stuff here. This thing up here, this thing that is stuck in the brownie is a Raspberry Pi. It's a more general purpose computer than the Arduino. It runs the Linux operating system. It runs a number of computer languages, including Python and Java and C, which are all good learner languages. And there's a lot of kits available for it that allow you to hook it up to input devices and output devices, which are a great way to prototype things. So let's see if we can find any projects that people do. Let's see. Let's look on the blog. The blog will have, Pi-powered Busy Baby Board. So this is an interesting one. So this is the Busy Baby board. So the baby is going to interact with the board. So this is interaction designed for, well, I guess bigger than an infant, smaller than a toddler, because I don't see the kid walking there, right? And here are the things to interact with. And on the other side of the board, we have the computer and the wiring and all that kind of stuff. That's what they made it out of. Okay. Let's see what else we have. View the archive. Here's a Pi. Let's see, have something. Well, Here's an electronic nose to detect fruit ripening. Okay. So how are we going to do that? Well, we have all kinds of things that we're hooking the processor up to make it work. Okay, here's a little bit more stuff. So we've got the fruit, and it's in a jar. Okay, and we've got sensors, and we've got all this kind of stuff. How do you interact with this? I bet you interact with this just on the screen. I don't know if they're going to show us a part of that. Let's just take a look. They're not showing us what the interaction is going to look like, but they're showing us what all the sensors might be. Okay. There's a vendor that sells all this kind of stuff. The Arduino, the Raspberry Pi. They're called Adafruit Industries, adafruit.com. And the young woman who is the president and founder of this she calls herself Lady Ada, and she's a pretty interesting person all by herself. But they sell all kinds of devices for this kind of stuff, for physical computing prototyping. Okay. Pretty interesting stuff. Okay. So let's see. Learn looks good. All the different stuff that they have. So they have the Arduino. They have the Raspberry Pi. They have a bunch of other small, affordable computing platforms. Plus, they have all these sensors and lights and all kinds of cool stuff. LCDs and displays, tools, all kinds of cool stuff. Okay, so let's get back to the course. How could these help you? Well, you could come up with a prototype of almost any kind of device. Okay, the classic things that we're talking about, where you can do kind of a low fidelity card prototype. Well, I think before I would want to, I'd want to build something from the physical computing kit. I'd probably want to already have a scenario or a use case, and I probably might want to have something like a storyboard, right, and get the whole flow of things down. But then you can actually go and build a prototype of the device, which is pretty neat. The other thing that we talk about here are software development kits, and there are a lot of software development kits that you can use for prototyping. There's a good discussion in the text about the difference between an API and an SDK. So an API is an application programming interface. So that shows you, typically you'll get a library of software that's usable with one or more computer languages, like say Python or Java or maybe C or something like that, and that you can use to prototype a number of things. Okay, and the API explains how to use those software components. If you have an SDK, you can even create, which stands for Software Development Kit, you can even create more components. So the idea is that on the software side, you can either buy component libraries from which you could build prototypes, or SDKs from which to create your own software components. or do a combination of the two. Use some of their components and some custom ones that you create. So, summary, what are we saying? So different kinds of prototyping used for different purposes and at different stages. Prototypes answer questions. So if we don't have any questions, it probably doesn't make sense to build a prototype. The final product must be engineered appropriately, so we really have to distinguish between the prototype and the final product. And there's a good discussion in the chapter of two approaches to prototyping on the software side. One, where you're building a throwaway prototype. So you're using tools that probably wouldn't scale up. Okay, they'd probably be good for 1 or 2 or 3 users, but not good for 100 or 1,000 or 10,000 or 1,000,000. Okay, so you know you're going to throw the prototype away. It's just, even though it's created out of software, you're as sure you're going to throw it away as if it were made out of cardboard. Okay. The other approach is kind of the approach that people are taking these days in agile software development, where they're using tools which will scale up eventually, and they are creating an evolving prototype of the system. Okay, and the idea in agile development is that by the time you're done, when you're done with all the sprints in agile development, that you really have a working product. So you're not going to throw it away. Okay, the product is going to emerge over the lifetime of the prototyping. Okay. So I think we distinguish those two in the chapter, the difference between a throwaway prototype and an evolutionary prototype. Okay, but whichever the case, the final product has to have the kinds of performance characteristics that you need in a final product. Two aspects of design, conceptual and concrete, and remember that what we're trying to do is to not have you get too bogged down in the details before you've got the conceptual stuff straight. Okay. To generate conceptual design, consider interface metaphors, interaction types, and interface types. Those are all things that we talked about earlier in the text. Storyboards, which are low fidelity prototypes, can be generated from scenarios or use cases, okay, or user stories. Card-based prototypes can be generated from all 3 of those as well. And physical computing kits and software development kits facilitate the transition from design to construction. The physical computing stuff is going to help us most on kind of custom devices, not your typical information system. Okay, but the SDK stuff has a lot of promise because there are plenty of software kits that we can use to help us to build prototypes for systems while we're doing this kind of activity. And that's it for the chapter. I'm going to say bye until next time. Bye-bye.